Good morning, everyone.
Morning.
Happy Friday. Anyone has any questions about what we did in the last class? We are almost done with this chapter except the last two parts where we are going to talk about the conditional probability and Bayes rule. And I think I will start conditional probability today after talking about the variance, how to calculate the variance. So if no questions, let me just start this. Your first homework for chapter 4 is due on this weekend, so make sure that you work on that. I already extended it, and there are 2 more assignments for chapter 4, so make sure you work on that. So last time we talked about the discrete probability model and continuous probability model, and then we started working with discrete probability model, and we looked at the expected value or the mean for that probability or discrete probability model. We worked on 2 examples. The first example we toss a coin 3 times and look at the number of heads, and we took as x as 0, 1, 2, 3. This one. And then we look at the individual probabilities, that the probability of getting no head is this, 1 head, 2 head, and 3. And then we look at the expected value denoted with EX or mu x. And then we multiply their corresponding probabilities. And then we added these. And this gave me the expected value or the mean or the average. So we get this. So that is the mean or the expected value. First of all, you need to know how to make the table. Once the table is there or you make it, check the first 2 probability rules, that the probability of each event is between 0 and 1, and you add up everything, it adds up to 1, and you can calculate the expected value. Once you calculate the expected value, how do we calculate the variance? So in earlier chapter, we talked about calculating the mean and the variance or the standard deviation. And for the standard deviation, we use the formula to calculate the variance. We use that. We look at x and then subtracted the corresponding mean and then did the square and then added all these observations and divided with n minus 1. And this x bar was the mean, the sample mean that we calculated. And if we were looking at the standard deviation of x, we did the square root of the variance. And this was the formula that we used. And again, we can do that using calculator also. But we are using the same concept what we did earlier to calculate the variance or the standard deviation. Once you know the expected value of a discrete random variable, you can calculate the variance. And again, we are not using this formula because now we are working with probabilities. So calculating the mean is different, not the same way how we did for earlier, sum of all the observations and divided with n. That's how we calculated in chapter 1. Now we know the probabilities of each x. So we multiply with their corresponding probabilities, like how here we did, and then we get the expected value or the mean. So we are going to use this expected value to calculate the variance. And how do you calculate the variance? You first calculate the mean that we calculated in the previous slide. I am sorry. So here, 8.128. First, you calculated the mean. So using the same example to see how to find the variance. To find the variance, what you do, first thing, calculate your mean. You calculated the mean by multiplying the corresponding probabilities. And it was 8.128. Once you calculated the mean, now when we are talking about variance, this is the formula we are using. For mean, we use this one. So we multiply x with the corresponding probability. And now you can see that we are subtracting the mean and x bar, or you can say mu x, since we are using the expected value of mu x. So either you can write mu x or ex. It is the same thing. So first, you need to subtract mean from each. So mu 0 minus 8.128, and then do the square, and then multiply with the corresponding probability. That's the extra part you need to do when you are calculating the variance. So variance is the spread around the mean, or the variations around the mean, when we say standard deviation, both in the left and right side. So when we are talking about standard deviation, we said that standard deviation cannot be negative because it measures the spread. So that's why we are doing the square, so that it won't be negative. So first thing, you subtract the mean from each of them, each x values, do the square, and then multiply their corresponding probabilities. And once you solve this, the sum of that is your variance. And when you do the square root of that, you get your standard deviation. The question can ask you to solve for the mean variance or for the standard deviation. So this formula gives us variance, and we know that standard deviation is the square root of variance. And standard deviation cannot be negative. So when you do the square root, you get both positive and negative values. So go with the positive one because your spread cannot be negative. So this is how we calculate the standard deviation or the variance using the discrete probability distribution table. And again, when you work with calculating the mean or the expected value or the variance, make sure that you check the first two probability rules. If those two rules satisfy, then only your mean and variance is valid. Otherwise, if you're not working with the right probability model, definitely your results are not considered as correct. Okay, one more thing. So we talk about in chapter 3 we talk about that we work with the population, but population is unknown to us. So we take a sample from the population, or a part of, or a subset of a small from the population. And let's say I take this sample, you take this, so everyone take one sample from the population. Again, we are working with sample, and we work in the previous chapter how to work with the sample so that our sample is bias free. So we work with random sample. When we are working with random sample, not necessary my sample is exactly same as your sample. Maybe some observations are same, some are different, maybe completely different, maybe completely same. So when I work with the sample, I will get a sample mean. You work with the sample, you will get a sample mean. And as we all work with the sample, we all will get sample mean. So we say that since we all get sample mean from the same population, whose mean we can say is better than the other. So since we are working with sample, and we are all working with random sample with the same size coming from the same population, we all get sample means. So when we say that when we work with the sample means, when we take the means of the means, or you can say as the sample size increases, sample mean gets closer and closer to your population mean. So there is a definition or a concept, we call it the law of large numbers. The law of large numbers says that as the sample size increases, or it says that draw independent observations. And again, we learn about independent. that knowing one is not going to affect the chance of other. Independent observation at random from any population with finite mean mu. The law of large numbers says that as the number of observation drawn increases, the sample of the observed value get closer and closer to the population mean. So sample mean get closer and closer to the population mean. So sample mean is a good estimate for the population mean. So again, when we are talking about sample mean, it is very important how to collect the sample so that our sample, because our sample represent or the results from the sample, we use those to talk about the population. So the sample should be chosen in a very bias-free manner so that the results of the sample that we used to talk about the population are accurate or better or worth considering. The next topic is rule for the mean and rules for the variance. So let's talk about the rules for the mean. Here they talk about 3 rules, but let me extend it a little bit. The rules for the mean. So first thing, let's x and y are your 2 random variables. Then mean of x plus y is the mean of x and the mean of y. And this mu represents the mean or the expected value. You can write it that. So this is our first rule. And again, the order does not matter. In the book or in the slide, the order is a little different. You can go that way. But I just want to make sure that we start with first random variables and then we apply the constant. So we say that the expected value sum is the sum of the expected values. So if you have 2 variables, x and y, and you know that you calculated their means. So first one, let's say we have this one that we just took, the one example we did with 0 to 10, Apgar score one. And the second one that we did using tossing the coin. So let's say I'm just taking a number that might not be the correct when you solve it, but let's say I have 2 random variables and I calculated their expected value or mean. Now, if I'm looking for what is the sum of these 2, it is fairly simple. Expected value of x plus y is their individual sum. So you can look at their individual expected value and then you can add it. Same thing, if x and y are 2 random variables and we are looking for the difference is also the same. So you calculate this and then you get that value. So here we are just talking about random variables. Now if we have x and y 2 random variables, but a and b, we have 2 constants. A and b are 2 constants. So here we are not talking about the random variable. We are just talking about 2 fixed numbers, or you can say so if you have these 2 fixed numbers, then the expected value of ax plus by is mu ax plus mu by, or you can write a mu x. And let me put here in this form so that it make more sense. So expected value of a fixed number is the same as it is. It does not change, but then you multiply it with the random variable. Let's say I'm using the same example, the value of x and y that we had it here, using the same. Expected value of x is 8.128 and expected value of y. And again, most of the time it's given to us. And if it's not given to us, we have the probability table. And then we can use that table to calculate those expected value. And what would we take 3.2? And let's say my A is 5 and B is 3. So we can use these values in this formula. So we can write as A is 5, x plus 3y So just substituted this 5 here and this 3 here because this is given to me. And then I can write 5 times expected value of x and 3 times expected value of y. And we know that the expected value of x is this. The expected value of y, and then you can solve it. So the constant multiply with the expected value, and same thing you can do for subtraction also. If you are working with ax minus by, you do the same thing. And sometimes you have only one random variable, but two constant, or two constant, one random variable. You can still work with the same way. So let's say I have one random variable x and two constants a and b, or fixed numbers. So we are looking for ax plus b is mu ax plus mu b. And we know that the constant for that is a mu x plus b, because you don't have another random variable. A times expected value of x plus b, because we do not have another another random variable, so you just write the constant and use the same example. We have 5 as x. A was 5 and b is 3. So 5 times ex plus 3, and you know this value. And then you can solve it. Here we have ax plus b, and if it's like a plus bx, you do the same way too. For this one, you can do a plus b ex, or y, whatever your random variable is. So when you have two random variables, again, you are looking at their expected value and multiplying with their constant. But if you have one random variable, the expected value of a constant is a constant itself, even if you have a random variable or not. And these are the rules that are explained here in this slide. So you can go through. This is the first rule that I explain in this, and then this I explain as third. So you have two random variables, their expected value, sum of their expected value sum equals sum of their expected values. And same thing, the difference. And here you have two constant but one random variable. And you can also add that we just did. A mu x plus b mu y. So these are the rules for the mean. And let's see how these rules are similar and how these rules are different when we talk about the variance. So rule for the variance, let me talk about it here. Questions? Anyone has any questions? Okay, if not, so the first rule is variance we denote with sigma square. So you can say sigma square x plus y is sigma square x plus sigma square. So same thing, sum of the variance we are looking for, it is individual random variable variances you can add. And when we talk about the variance, we are talking about the square. We are looking at both sides of the mean. So either you look at the sum or the difference. Variance is positive in both cases. That was not the case in the mean. So when we are talking about the variance, either you look at the sum of two random variables or the difference of two random variables, it is their sum. And you can see it here in your slides. If x and y are independent. And again, when we are talking about two random variables, in variance, we look at that first. If the variables are independent or they are dependent. And when we are looking at if they are dependent, are they correlated? And if they are correlated, this rule will change a little bit. When we are talking about two variables, they are independent. So that means they have no correlation, and their correlation is 0. That we learned in previous chapter, chapter 2, what is correlation when we are looking at their linear relationship. If they have no linear relationship, then it is just individual variances sum. But if they have a correlation, then we add that correlation part. And that is, you have the same part here, but twice the correlation, 2 times the correlation times the standard deviation of x times the standard deviation of y. This is the standard deviation of x, and that's the standard deviation of y. And again, since now we are not doing the square, when you subtract, you will see a negative sign. And this negative sign is not coming because we are subtracting here. This negative sign is coming what kind of correlation you are working with. Is that correlation positive or is that correlation negative? If that correlation is negative, you will see this negative sign and then positive sign. One more thing, when you are working with two random variable and looking at their variances x and y, and you have two fixed numbers, two a and b, or two constant, so variation or variance of x plus y square is the same as, you can say, the variance of a, sorry, let me just write, ax plus by, because we are taking a and b as the constant. So it will be variance of ax plus variance of by. And that, when we are talking about variance, the constant, when we are looking at the variance of a constant, it is the square of that constant. A square variance of x plus b square variance of y. And when you know variance of x, plug that value. And we just calculated the variance using the table from 0 to 10 Apgar score. You can plug that here. And similarly, if you know the variance of other one, you can plug. And these a and b are your constant numbers, constant. So it can be 5, 3, 2, whatever is given. Do the square and multiply. And here we are talking about two constant. In your rule, they are talking about you have two constant, but only one random variable. So variance of a random variable is the square of it. So you can write it at like this. But if you are looking at the constant and there is no random variable, if there is no random variable, then that constant, the variance of that constant is 0. So variance of the constant with the random variable is the square of that, like how we see here. But if there is no random variable, how do you find the variance for that? So that will be 0. So these are the rule for mean and variances, and you have some questions in your second homework assignment on the rules for mean and variance. Apply those rules, and there is question 6 and 7 where it says that W is x plus y. So look for x and y, and then the question is asking you to solve for W. So first you add your x and y using the rule for the mean or variance. And in question number, I think 7, this W is not given, but question number 7 is the coming from question number 6. So it's the same question, but asking two different things. So make sure you read the question carefully. And if you have any doubts, feel free to send me an email. So that ends our 4.4. 4.5, we already covered probability rules. We covered general addition rule also. And this is the topic that we are going to cover. We kind of cover this, but we need to use this multiplication rules for conditional probability also. We use the multiplication rules for independent event. And for independent event is probability of A intersection B was their product. But we will use this rule in conditional probability also once we understand what conditional probability is. Tree diagram, I have been explaining you questions using tree diagram. Tree diagram is a pictorial representation of what information you have and what you are looking for. You don't have to use a tree diagram. You can make a table also. And in your homework assignment, the questions towards the end, where the questions are for unconditional distribution or conditional probability, that they did not provide you tree diagram. They provide you the table. But you can use the table also. Again, if you don't feel comfortable using the table, you can convert those tables into your tree diagram, and then you can use that. And table, again, we learn what is a table or two-way table. You are using the same two-way table. You are looking for the marginal to see what is the total when you start the problem making with the tree diagram. And Bayes rule, important application for conditional probability. Bayes rule, I will not start today. I'll start on Monday. And then we will do a couple of examples on that. But except Bayes rule, hopefully we will be able to finish everything today. And independence again. So we use independent event intersection of these two is the product. And then we'll see how do we apply this when we talk about conditional probability. So read the word conditional probability. When we say conditional probability, so that means I'm talking about two things. First, I'm looking at the probability part, but what kind of probability? The probability of something under a given condition. So when I'm looking for the probability of certain event under the given condition, I'm looking for the conditional probability. So let's see first, how do we write the definition of conditional probability, or what is conditional probability? So we talk about all these. Take a look at that, and if you have any questions, let me know. So the probability we assign to an event can change if we know that some other event has occurred. So if the probability will change, and we say that if we know the probability of A happen, not going to change the probability of B, we call them independent events, right? But what happens if we know if we know the probability of A that happened already is going to affect my probability of B, then we are talking about the conditional probability. What are the chances when this event has already happened, how it is going to change my second event? When we are trying to find the probability that one event will happen under the condition that some event is already known to have occurred, we are talking about conditional probability. So looking at the probability of the second event under the first condition that is given to us. And this is the definition of conditional probability. So let me write here in the simple word. So when we talk about conditional probability, so let's say I have two events, A and B. And if I'm looking for A, this, so this thing is said, or how do we say it? We say that probability of event A, and this part we say given that event B has occurred when the experiment was performed. So when we are saying probability of A given B, and let me write it in a better way, it's like this, not like this. So A given B, so this slash is called given. So when we are looking for the probability of this part, and this is already happened, so we know that this is already done. We are looking at the probability of A under the condition that B is already happened, then we are talking about conditional probability. And when we are talking about conditional probability, the formula that we use is A given B. So what is given to me, that goes in the denominator. So when I'm looking for probability of A given B, I know the probability of B, and probability of A given B, the numerator is their intersection part. What is common between both? So probability of A given B, that's how we read it for conditional probability. And whatever after this, that is given to us. And whatever we have in the numerator, that means we are trying to find the probability of this, which is contained in this part. So I'm looking at the probability of A or the part of A that is contained in B. So this is the formula that we use for conditional probability. And since we are dividing with the probability of B and we know that it's already happened, so it should be greater than 0. It should not be negative or it should not be higher than 1. So we are saying that it should be greater than 0 because we are not dividing with something less than 0 here. So this is the formula for conditional probability. If I write it like this, do you think anything will change here? Do they both talk about the same thing, this and this?
Wouldn't it be the other way around? Probability of B given A?
Perfect. So we are still talking about conditional probability, but now A is given and we are looking for the probability of B under the given condition A. So since A is given to us, we divide with A. And your numerator is still the intersection because we are looking for the common part, or what is the probability of A and B that is common. Or you can write it, if you write B intersection A, since B is on the numerator, this and this is exactly the same thing. A intersection B or B intersection A, we are talking about the common part between A and B. If this is A and this is B, and I'm talking about this part, I can say that this is A intersection B or B intersection A. So intersection is just telling me that it is the common part between A and B. So either you can say this or this. So numerator does not change. Numerator remains the same. But the denominator will change depending upon what information we have, what is given to us. And the given to us is this even, which is on the denominator, or when we read it, we said that A given B. So when we are saying probability of A given B is their intersection, dividing with the probability of B. If we know two things from here, we can find the third one. So if we are solving for this, definitely we need to know these two things. But what happens if I have this information and I have this information? Then can I find their intersection or the common part?
Did you multiply them?
Just multiply them. Perfect. So this, if I'm looking for the A intersection B, I can say that probability of the event that is given to me, and then probability of the conditional event A. And this is called your multiplication rule for conditional probability. So this rule does not come from anywhere, or you don't have to memorize. This comes from straight from this formula or this rule for the conditional probability. So if we know the conditional probability formula, we can find this part. And again, intersection is the one that changes our general addition rule, independent event, disjoint. So again, if we are talking about the conditional probability, in the addition rule, we can replace this with this. So when you are looking for, and again, what is information is given, A intersection B can also be written as probability of A times probability of B given A. And you can look at this previous example, this one. So if you multiply these, this will also give me probability of A intersection B. So probability of A intersection B, the multiplication rule is in two forms, depending upon what you are looking for. If you have A given B, then use this. If you have B given A, if you know the probability of B that is given or the probability of A that is given, so you can take a look, which one you want to use. So this is called your multiplication rule. In conditional probability, and I'm using the general addition rule, and this part will be replaced with this depending upon if you know the probability of given B or given A. So it can be any of them depending upon what information we have. So that is your addition rule for conditional probability. And this is one, and the second you can write. So this part remains the same. The only part that changes is now I have given A. So this is the only part that is changed. So these are your condition. These are coming from your conditional probability. So again, understanding the concept of conditional probability takes some time, but again, it is not hard to understand. Let's say if we know we are talking about B given A, and the probability of A is greater than 0. And if I know what my probability of A is, let's say it's 0.2, and I know that the intersection of A and B is 0.123 something, then I can divide these two and I can find the probability of B when A is given to us. And similarly, if this part is given to me and this part is given to me, I can find this. In your homework assignment, there are a couple of questions where it's asking you to calculate the conditional probability. So take a look at those. Again, when we are talking about conditional probability, either A given B or B given A. And I have one more information with this. The question provides you the probability of A, B, A given B, or you have some information, and on the side it says that A and B are independent events. And when we are saying A and B are independent events, how is this applicable to my conditional probability? Or what does it mean when I know that A and B are independent events and I'm looking for the conditional probability of A? First of all, what information I have before conditional probability about the independent of two events? When I know that two events are independent, their intersection is the product of these two, right? So I know that intersection part. And let me just plug this part here. And what will I get? Probability of A given B is probability of A times B, and I'm replacing this with this, divide with the probability of B given that B is greater than 0. So I can cancel it out. So probability of A given B is the probability of A itself. And what does that mean? So when we are looking at conditional probability, so we are looking at that part of A which is contained in B. When these both are independent, and knowing the chance of one is not going to affect the chance of other, then why do I care about what is given to me as B? Then probability of A is A given B is the probability of A itself. Because when B is not going to chance A, then I don't care about the probability of B. They are independent. So when you're talking about independent event, conditional probability is very easy to work with. And again, there is no conditional probability because you're just looking at the probability of that particular event. Because B is not going to affect or change anything in A, even though B is given to you, because they are independent of each other. So that is, again, an application of conditional probability. When you work with the conditional probability and you know that events are independent, then there is no need to work on the conditional probability. You can just look at the probability of the event that you are looking for. Because even though we know B is already happened, we know the probability of B, but it's not going to change anything in my A. So these events are independent. So I will just say that conditional probability of A given B is the probability of A, or the conditional probability of B given A. This is not going to change anything, so it is the individual probability. So this is also one of the rule for conditional probability for independent events. Now let's go back to the slide. So the probability that one event happens given that another event is already known to have happened is called your conditional probability. When probability of A is greater than 0, the probability that even B happens given that A happened is found to be this. So what is given in the denominator and then intersection of both in the numerator. And general multiplication rule that we just talked about, this rule comes from here. You multiply these two and then you get the intersection part. So probability of A intersection B is the probability of one times the conditional probability of the other. So probability of B given A is the conditional probability that event B occurred given that event A has already occurred. And this is called your general multiplication rule for your conditional probability. Questions? And tree diagram, how to read the tree diagram to see what is given to me or what is conditional probability, what is the intersection and all that. So let's just take example. You toss a coin 2 times and you get either a head or a tail. And we have done this example multiple times depending on how many tosses we have. So here we are tossing a coin 2 times. And the first time we get a head or a tail, the chances are 50-50. Second time also, you get a head or a tail, the chances are also 50-50. 50-50-50-50, right? So now, how do we represent each of them? Or what is this half means? Or what is this half means? What is this half, this half? And since it's half and half, well, so it's a little confusing. Some numbers here so that you know what exactly we are talking about. So that it's not like which head I'm talking about or which tail I'm talking about. So let's say this one. And this should add up to 1, and it's not adding up to 1. So I'm taking it as 2/3 and 1/3. And just taking this. The first is this, the second trial. And let's say these are dependent or independent. I don't know right now. We are just looking at this one. So here, getting ahead is not going to depend. But let's say when I do the second toss, the coin is not a fair coin. And it gives me 1/3 and 2/3. So head is first time the toss is fair coin, I get the probability half, and second it was not fair and it's like 1/3 and 2/3, just for your reference so that we know how we work with. So what is this half? It is the probability of your head in the first trial, right? What is this 1/3? How do we write this? To write this, first of all, we say that how did I reach here? This is not my first trial. So I came to here knowing that there was a head in the first trial, right? So what was given to me? The head was in the first trial. And getting a second head when the first head was, when I get the head in the first trial. So this is 1/3. So how do we write this part in terms of probability or conditional probability? So this is the probability we are looking for. So this is head is given that I get a head in my first trial. Same thing if you're talking about this tail. This tail, you don't get this tail until you get this head first. So given that you get head first, and this is the probability of tail, this is 2/3. And since we are saying these two events are independent, this half is not going to affect the probability of this, then probability of two heads. So when I'm looking for this head and this head, so I'm looking for what is the intersection of this. This is the probability of the first head times the probability of the second head, because they are independent events. And let me just write 1 and 2 so that it makes more sense. So this is the probability of first head times the probability of second head, which is half times half, because the evens are independent of half times 1/3. We took it as 1/3. And then you can solve. So again, when you look at the tree diagram or the table, first of all, start identifying what is this? How can I write this in probability notation? How can I write this in probability notation? What does this half means? It is just the probability of tail. What is this? This is, I get the probability of t given that there was a tail in the first trial. And then this is half. And then you can find the condition, you know the conditional probability. Again, if you know the intersection and their individual probability, then you can find the conditional probability. All right. So this was about how to read a tree diagram. And our next topic is Bayes rule. And okay, so I think I mentioned this part before. Addition rule for disjoint events. We talk about only 2 events in the example, but let's say if you have 3 or 4 or 5 events in the same Venn diagram, one or more events A and B, it is the sum of all those events. And same thing if you are looking for the intersection, and here we have only 2 events A and B, and let's say if I'm talking about, I have this Venn diagram, I have, this is A, and this is my B, and I have another event C, then how do I identify these intersections? So if I'm talking about this one, what is this means? So this is between A and B. This is the intersection between A and B, right? So these are my 2 events A and B, and this is the common part between A and B. And let's use the same and look for what is this. Anyone?
B and C.
B and C. Perfect. And similarly, you can pick another color and this one. This is A and C. And when I look at this one, let me see if I can see a different color. If we look at this part, this is the common part for all. So this is A intersection B intersection C. So there is a very similar question in your homework assignment where it's asking you what is the intersection of 3 events, and numbers are given to you. Take a look at that. And when we are talking about more than 2 events, again, it's not just the intersection part between this. It is the intersection that is common in all 3 of them. Questions? So it's this one. All right. Oh, so it's already 11:50. So I guess I'll stop here. The only topic that is left is Bayes rule. And Bayes rule, again, we will talk about how to use the formula or how to use the tree diagram and talk about the Bayes rule or the table and work with that. And most probably we'll work on 2 or 3 examples. There are not very many examples here in the slide, but I will upload. I think I already uploaded, but if not, we'll upload a couple of examples. And if you have time, try to work on the weekend. If not, after Monday's class, and then you can do. Then I think you will be able to do your homework as well as quiz for this chapter. Thank you, everyone. Have a nice weekend, and I'll see you guys on Monday.
Thank you.
You're welcome.